All right, so this is the review for Chemistry Exit Ticket 102. We'll be taking this on Thursday. All right, first of all, as we talked about in class, atomic radius increases from right to left and from top to bottom. So francium is the largest element because it is both all the way left and all the way down. Okay, if we had three elements, A, B, and C, okay, C would be the largest, A would be the smallest. Okay, remember, you can tell what element you're looking at by the electron configuration. Just use it to find it on the periodic table. A catalyst, by definition, lowers the activation energy required to start the reaction. So we have the reactants, and they gain energy, gain energy, gain energy, gain energy. Once they've reached they've gained an amount of energy equal to the activation energy, that's when the reaction takes place. So this amount of energy is called the activation energy. So a catalyst lowers that energy, right? So maybe instead of having to go all the way up here, maybe it only has to go to here. And so it makes it easier for the reaction to occur because you need less energy. This is a cooling curve. You can also have a heating curve. They're the same thing, except one, the temperature is going down, and the other, the temperature is going up. Okay? With a cooling curve or a heating curve, you'll notice that there are some slanty bits and some flat bits, and a slanty bit and a flat bit and a slanty bit. So here's the thing. Remember, temperature is really the average kinetic energy of the molecules. The faster the molecules are moving, then the higher the temperature. Okay? So in a gas, you have a high temperature, you have a lot of motion of the molecules, and they're far apart. So as the temperature goes down, the molecules are slowing, and then they slow down enough that they can start attracting each other, and they get closer and they closer. Temperature isn't changing right now because they're just getting closer together. And then at some point, they get as close as they can without the temperature going down. So the temperature goes down, 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 down. And then, now, see, you have a liquid right here. Right here, you're in a liquid state. Okay? And then you get to a point where the liquid molecules can't get any slower without getting closer together. And so now the energy lost is allowing the molecules to get closer and closer together, and they're slowing down, and then you have a solid, and then the temperature starts going down again, and that's a cooling curve. Okay, so if you went from point X to point Y, you would be changing from a gas to a liquid. This is the phase change. This is a phase change, liquid to solid. On the heating curve, it's the same story. But we're starting with a solid, and we're melting, and then we're increasing temperature. We're a liquid that's getting hotter and hotter and hotter, and then our liquid starts to boil. And so the temperature stays the same as it boils, and then the gas, once we get to a gas state, the temperature starts going up again. Okay? If we're losing energy, it goes the other way. So we start with the gas, and we're cooling. Then we're condensing. Now we're a liquid, and we're cooling. And now we're freezing. And then we get to a solid, and we're cooling. All right. So here's the idea with this one. We have a test tube of...
We need Omarion Dawkins out front, please. Omarion Dawkins out front.
All right, we have a test tube of sodium hydrogen carbonate, and we're going to heat that. And as we heat that, it decomposes. And we notice that there are some water droplets forming on the side of the test tube. And when we bring a burning splint, this is a burning splint, all right, into the test tube, it goes out and it no longer burns. So the question is, what put out the burning splint? Well, a lack of CO2 is not going to cause it to go out. Okay, so that's not the answer. A lack of H2O is not going to cause it to go out. That probably helps it. Okay, oxygen, the presence of oxygen would help it burn faster. Okay, oxygen is loved by fire. Okay, so it's not that one. It instead is this one. Okay, the water vapor is condensing on the side of the tube, and that's causing the condensation that you see. And then the CO2 is putting out the fire because there's not enough oxygen present for the fire to continue. All right, so here we have an example, and I'm gonna erase this. All right, so we have this generic equation. W plus X produces Y plus Z, and Z plus Y produces X plus Z. All right, so this is at equilibrium. We have the forward reaction and we have the reverse reaction. The question is, if we decrease the W, what's going to happen? Okay, and the answer is going to shift to replace the W that you took away. Okay, so anytime you add to the products or take away from the reactants, it's going to shift towards the left. If I add reactants or I take away products, it's going to shift towards the right. Okay. All right, so here we have sodium hydroxide. This is a base, all right, as in acid and base, so don't drop it unless you're a DJ. Okay, and then the sodium is a positive ion, and the OH is a polyatomic ion called hydroxide, and it is a negative ion. So when we put these in H2O, into water, they dissociate and become a sodium ion and a hydroxide ions. So first of all, this is an electrolyte solution because it contains ions and conducts electricity. And they dissociate and they are ions. They are not atoms. I mean, they are atoms, but they're atoms with a charge, so they're ions. Okay? They're not molecules, they're ions. All right, if we have an electron configuration that's 1s2, 2s2, 2p6, 3s2, and we say that that is the ground state, all right, we know that it's going to lose its outermost s and p, as those are the valence electrons. And we look at the periodic table, okay, and we see, all right, hydrogen and helium, that's your 1s1, 1s2, and then lithium and beryllium.
Don't forget to stop by and get your Chick-fil-A sandwich if you haven't gotten it already. It is right outside the front office in the atrium. You can't miss it on a decorated table. All right, have a good day. We appreciate y'all.
All right. So helium and hydrogen are your 1s1, 1s2. Lithium, beryllium are your 2s1, 2s2. Boron is your 2p1, 2p2, 2p3, so forth. Neon would be your 2p6. And your 3s1 is sodium, and your 3s2 brings you to magnesium. All right? So we know that this is a metal. It's a metal called magnesium. It's in group 2. All right, so the electron configuration and the periodic table are telling us that it's going to lose 2 electrons and be a 2+ ion. Right? So when you're given the ground state electron configuration, the first step is to find it on the periodic table. Then you're going to decide if it's going to gain or lose electrons, and then what charge is it. Okay. Iron 2 oxide is the name. What is the formula? Well, we know that iron is Fe, and we know that the metal goes first. This tells us that the iron is a 2+, and we know that oxygen is also a 2+. I'm sorry, a 2-. Right? So oxygen is a 2-. These numbers equal 0, so our final formula would be FeO, and that would be iron 2 oxide. Okay. And then remember that atomic radius from right to left is increasing, and from top to bottom is increasing. And that's it. Hope this helps. I'll see you tomorrow in class. Stay curious.